So this is lesson 86, and if we were in class, we would do this cute little thing and we'd talk about bugs walking around the unit circle, but I don't want this video to be too long, so we're just going to kind of get to the gist of things. So you guys can flip forward to the third page of this lesson, page 36. I'm just going to zoom in a little bit. So we're going to start right here on exercise 3. So it says, using the chart, create a graph for y equals sine theta on the interval from 0 to 2 pi. Use the unit circle to find the sine values for these quadrantal angles. We'll worry about this extension part in a second. So right here, I'm going to draw the unit circle, and I'm going to label the points that correspond to these angles. So first I'm going to put the angles on the graph. So my angles I'm working with are 0. I'm going to put them kind of further out so I have room for some other stuff. Pi over 2, pi, 3 pi over 2, and then 2 pi is going to come up here with 0. Now, in order to find the sine of theta, we spent a lot of the last lesson talking about on the unit circle how sine is the y value of that point on the unit circle. So I'm going to label each of these points. So it's 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So when I fill in these sine values, all I'm really doing is I'm taking the y value. So when I'm at 0 degrees, which is blue here, this blue squiggly 0, the value of sine, circled in green, is also 0. When I'm over here at pi over 2, the y value is 1. When I'm over here at pi, the y value is 0 again. And when I'm over here at 3 pi over 2, the y value is negative 1. And then when I go back over to 2 pi, I'm back where I started, and the y value is once again 0. Okay, so when I move over to graph this, my angle is kind of like the x-axis. We're going to call it the theta axis, but it's x. And my sine value, my function, is the y. So based on this interval, just kind of count over about 4 or 5 spaces and put down the y-axis. And then put the x-axis right in the middle. Okay? Now, because of these kind of weird angles, I'm not really going to label my x-axis with my normal like 0, 1, 2, 3. I'm actually going to use these values for the angles. Now, if you type in pi over 2 on your calculator, that's about 1.57. Pi is 3.14. So those are still numbers, but we can't, we're going to use those irrational values. So nice spacing is usually to take 2 spaces on your graph and put down the pi over 2, which remember is equivalent to 90 degrees. Then put the pi down, then the 3 pi over 2, and then the 2 pi. Okay, so from there, I'm going to start to graph my points. So I know this is very different, right? This scale, okay, it's really just working with what we have in the table to make a good scale like we always do. So my first point is 0, 0. So I'm going to graph 0, 0. I should have probably done this too. I'm just going to put, because these are nice normal numbers in the y direction, I'm just going to put a 1 and a negative 1 here. Okay. So my next point is pi over 2, 1. Now I've set it up so I just have to go over to here and then up to 1. Okay. Then we have pi 0. And then we have 3 pi over 2, negative 1. And 2 pi 0. So if I fill this in, I'm not going to draw it like a choppy graph like that. If we think about the pi over 4, which is in the middle here, that's 45 degrees. That value is radical 2 over 2 for sine, and that's actually 0.7. So it actually does more of an increase in the beginning, and actually kind of makes like a mountain valley type look. So this is what the graph of sine looks like. Okay. Now, when I look at this, I'm going to do a different color for more of sine, but that is one chunk, or it's going to be called one period of sine. So remember, if you know that, that's good. We're just going to follow the directions and extend it out a little further. Okay? So here, I'm just going to kind of keep it simple. This is pi. This is 2 pi. So I'm going to skip another 4 spaces to get to 3 pi. Okay? Same deal here from the y-axis. I'm going to go back 4 spaces to get to negative pi. Now I'm also going to label it a little bit more. I think it's kind of obvious that this will be negative pi for 2 in here. 0, negative pi. Over here, maybe not as obvious, but counting, this is 1 half, 2 halves, 3 halves, 4 halves, and this is 5 halves, or 5 pi. Okay? Now, if I just keep going around my circle, right, my y values are just going to keep following the same pattern. So this one chunk of sine I have, this one period, will just continue and do another bump as it heads to 3 pi. If I'm going in the other direction and I continue this wave, it's going to go back to negative pi. And that's where this graph wants me to stop. But if I continued in both directions, I would just continue to get that same picture forever. Okay, because I could continue to go around my circle. So let's start to look at some qualities of the graph. And one thing I should have done before too is I should have labeled my axes. So this is the theta axis because that's what's used for x in this case. And this is the y-axis. And one other thing, this is kind of gives us a reason that we have theta because x is already something else. Remember, x is cosine on the unit circle, so to use x for the angle as well would be kind of confusing. So they use a separate angle. So in our properties, what is the y-intercept of sine? Sine always passes through 0, 0, so the y-intercept is 0. The maximum value of sine, this is maximum y value when we talk about the maximum of a function. So the highest sine theta goes is 1. The lowest it goes is negative 1. And now we're going to get into 3 qualities that we talk about in all trigonometric functions. So the midline of the trigonometric graph is the horizontal axis that is used as the reference line about which the graph of the trigonometric function oscillates or goes up and down. So if I look at sine of theta, this is that midline, and that midline just has the equation y equals 0. The distance from the midline to the max value, okay, so any of these bumps from the middle to the high is known as the amplitude, and so the amplitude of sine of theta is just 1. And then our last quality, which I did say before, is the period of the graph. So the period is how long it takes to complete one cycle. So if I look at sine of theta, here's the beginning of its cycle, and here's the end. That's like the black piece of the graph. So the time it takes to complete is 2 pi. So all of these qualities are very important. We've just learned a new parent function, sine theta. Okay, we can do things to sine theta transformations just like we do to any other graph.